Alright everybody, welcome to the second video in the series, Hexadecimal. Now, if you can already convert your MAC address into binary and then to decimal, you can skip this video. Otherwise, let's get started. Alright, so remember back to when you learned about the OSI model. You learned that at layer 2, we called it the data link layer, and a MAC address is added to the packet, and then we call it a frame. And that switches use the MAC address to make forwarding decisions for local traffic. So here in the OSI model, for networking, when we hit layer 4, we add a port number, and then we call it a segment. And then when we get to layer 3, we add an IP address, and then we call it a packet. And then when we get down here to the layer 2, the data link layer, we add a MAC address, and then we call it a frame. And remember that switches, bridges, and wireless access points all use the MAC address to make forwarding decisions. So MAC addresses are a layer 2 function used for making forwarding decisions by layer 2 devices such as switches and wireless access points. And they're used for local communication, inside my network. Alright, so hex is important because hex is used in MAC addresses and as the IP address in IPv6. So while IPv4 focuses on binary, IPv6 is constructed on hex. Alright, so how do I find my MAC address? Well, you can do it a couple different ways. It all depends on your operating system. You can either hit start and then type in the letters CMD, Charlie Mike David, in the run box. That'll bring it up. You can hit start and then all programs. Then accessories, and you can look for it in there. Or if you have Windows 8 or better, you can just cycle through to the end of your programs and look for it there. On my computer, it was near the end. I scrolled all the way to the right, and then there it was, command prompt. So you want to open that up. And when you do, it should look like something like that. And then it has, obviously, your computer name in there. And then you're going to type in ipconfig space / all. Now, if you just type in ipconfig, if you remember from your networking class, ipconfig will just show you like your IP address and stuff, but just very basic information. You only see like 4 lines. But if you do /all, you get all the information for all NIC cards on your computer. And any virtual interfaces on your computer. So if you're running any VMware or something like that, you'll also see information for that. So when I run it on mine, this is what I see. So scroll down, you should be able to find a physical address. Remember, for some reason Microsoft and Cisco always seem to name things differently. Like if you're doing a trace route on a Cisco router, it's trace route. But if you go to a Microsoft PC, it's trace cert. And then if you go to a router, it's always a MAC address. And if you go to anything in Microsoft, they call it a physical address. So you should find a physical address. And then you should see a 12-digit hexadecimal number. And then depending on your operating system, what version you're running, you might also see an IPv6 address, also depending on your network. And we can see this IPv6 address, blah, 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 blah. It looks pretty big and nasty. And we're like, oh, God, what's that? Trust me, it's much easier than IP4, and we'll get into that in another video. So for now, we're just going to focus on the MAC address. So take a minute, pause the video, and write down your MAC address. And if you couldn't figure this out, you probably should be networking. But anyway, just write down my MAC address here, because we're going to convert this. All right, your MAC address consists of 12. It's a 12-digit hexadecimal number. The first 6 digits reference the manufacturer, and they refer to this as the OUI, the Organizational Unique Identifier. And then the second 6 digits are basically the card serial number. Now, there was a story from a few years back, and I don't remember what state it was in, but basically some guy thought he was smart, took his laptop to like a McDonald's or someplace like that, ordered a drink, sat down in a corner, used their wireless, and then he got in the internet and he hacked some company. Well, the FBI was called, and the FBI obviously were like, hey, we traced it back to this McDonald's. So then they went to the McDonald's where the IP address came from. So they knew the time and the date when this had happened. So they went back to McDonald's, they gave them this information, and McDonald's was able to pull up, what was ordered at the time, and their security tapes. Most of these places like Starbucks, McDonald's, any place typically that has public Wi-Fi, also has security cameras. And if you look around in the ceilings, you'll see like a black ball or something like that. That's the camera. So they figured out what laptop it was by the MAC address. So they knew what MAC address had pulled that IP address or had done that stuff. And they got that all from the router at McDonald's. And then they used the 6-digit OUI, the manufacturer, to see what laptop manufacturer made that, or what NIC card was sold to what. So it was like a Dell. So then they just used the camera footage and found the dude that was sitting there with a Dell in the dining room. He had like a latte or something. So then they went back to the register records and they found out that the guy had used his credit card to order the latte. So again, they knew exactly the time, the date, and then tracing everything back, they were able to find him and then prove, and then he obviously got convicted and it was bad. So let that be a lesson to you. If you're ever going to hack, make sure you use cash and not your credit card. So moving on. So first 6 digits are the vendor, who makes this card. And then the second 6 digits are the serial number. So let's say that Joe Donut wants to start making network cards. He has to go apply with the Internet Association. They assign him these first 6 digits. And then he can use these last 6 digits to track different NIC cards and what vendor he's selling them to. So Broadcom makes NIC cards, but they may sell those NIC cards to Dell, and they may have a whole series of serial numbers that they sell to Dell. So make sure you understand that the MAC address has 2 parts, the vendor and then the serial number. The first 6 digits are the vendor, second 6 digits are the serial number, and they can be used to track information. All right, so to summarize, a MAC address is a 48-bit, 12-digit hexadecimal number used at layer 2 by switches for local network communication. So if you and I are in the same room or the same network, I'm in sales, you're in sales, you're on one side of the room, I'm on the other side of the room. If I'm going to send you a text or an instant message or some file on my PC, it's going to go from my PC to the switch and then from the switch to your PC. So it never hits a router. So MAC addresses are used for local communication. All right, hexadecimal starts at 0 and counts up to 9. And then when the double digits start, it substitutes the double digit numbers with letters all the way up to 15. And 15 is the highest number you can have in hex. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So A is 10, B is 11, that kind of stuff. So, looks pretty easy, huh? Just remember that F or 15 is the highest number we can have in hex. There is no 16. But there are 16 total digits, 1 through 15 plus 0. So there are 16 total hex digits. Each hex digit is a nibble. And if you remember, a nibble is 4 bits. So it takes 8 bits to make a byte, and it takes 2 nibbles to make a byte. So it takes 2 hex digits to create a decimal number. And then last, a MAC address of all Fs is a broadcast. If you remember, a broadcast address has all ones in the host portion. And that means it goes out to all the hosts on that network. So there are broadcasts in hex or in MAC addresses as well. So when we see a MAC address of all Fs, that's a broadcast. So when my PC first starts up and he's looking for things, he has no idea what anything is. He doesn't know the MAC address of the email server or the DNS server or the DHCP server. He sends a broadcast a MAC address of all Fs out to the router and says, "Hey, where do I go?" And when to the switch, and when switches get these all F MAC addresses, they broadcast them out all ports, and they basically become hubs. But we'll have another video on broadcasts and collisions later. So don't forget, now this shows like the nibble superior, nibble inferior. Don't worry about that. Just make sure that you understand that a nibble is 4 bits, and it takes 2 nibbles to create a byte. So my MAC address is 48 5B 39 1C 02 6B. So let's focus on the first 2 digits. So the first 2 hex digits are 4 and 8. So hex is usually written like this with a space between every 2 digits, since it takes 2 digits to make a decimal number. In order to convert hex into decimal, you have to convert hex into binary, and then from binary you go into decimal. So that's why we had the binary video first. Alright, so we're going to start with 48. So remember, each hex digit is converted individually. Then the conversion of the two hex digits are brought together to form a byte, and then the byte is converted into decimal. So let's work this live and I'll show you what I'm talking about. So if you remember binary, this was our number line in binary. So we started at 1 and we doubled it 7 times. 2, 4, 8, 16, 32, 64. But in hex, it gets much easier because we only need 4 numbers in our number line. 1, 2, 4, and 8, because we're only dealing with nibbles and not bytes. So if you're going to convert hex into binary, you just need to use 1, 2, 4, and 8. So here we are in hex. And I'll grab my pencil. So remember, I'm going to convert 4 and 8. So this is how you do it. Remember, hex is always shown like 2 digits separated by a space or a comma or a semicolon, something like that. And then we put those two together like this. So 4 and 8. So which of these numbers make up the number 4? Well, 4. And then these other numbers have to be 0. Which of these numbers make up 8? Well, 8 and then 0. So 48 in hex is 0, 1, 0, 0, 1, 0, 0, 0. 0, 1, 0, 0, 1, 0, 0, 0 is 48 in hex. And then if I just convert this number from binary to decimal, then I'm all set. So I would know what 48 is. So pretty easy, huh? All right, let's do the next one. I think the next one was 5b. All right, so 5 and b. Now, we can't convert the letter b, so we have to change that to its number form, which is 11. Remember, a is 10, b is 11. So 5. How would I make 5 out of these 4 numbers? Well, 4 and 1 is 5. So then 2 and 8 have to be zeros. And then how do I make 11? Well, 8, 9, 10, 11. So this has to be 0. So 0, 1, I'm sorry, yeah, 0, 1, 0, 1, 1, 0, 1, 1 would be 5b in hex. So 5b converts to that, and then if I would convert this binary number into decimal, I'd be all set. So much more simpler than binary, but then you still have to convert the binary into decimal in order to get, from hex to decimal. So the next number in my Mac was, I think, 39, but let's do a different one. Let's do 1C. Actually, let's just make up one. Let's do like CD or something. All right, so we're going to do C and D. So we know C is A, B, C, so 10, 11, 12. So we're going to convert 12. And then we know D is 13. So 12 and 13. So which of these numbers make up 12? Well, 8 and 4. And then this has to be 0, this has to be 0. And then what makes up 13? Well, 8, 4, and 1 equal 13. So 1, 1, 0, 1. So 1, 1, 0, 0, 1, 1, 0, 1 equals, well, we'll just say equals over here. So CD equals 1100, 1100, and if I convert that to decimal, I get 205. So CD equals this, and that equals this. So that's how I would convert from hexadecimal into decimal. I got to convert to binary in the middle, or at first. So now for practice, hopefully you were able to find your MAC address. Go ahead and convert your MAC address into binary, and then convert it into decimal, and it should come out into 6 decimal digits. Now, just as an FYI, when hex is written, they write it different ways depending on what they're doing. Sometimes you'll see 0x, and then you'll see the hex number, so like 1C. And then the 0x tells you, hey, I'm going to see hex. Or you'll see like 1C and then a little tiny h, and that tells you that it's hex. So if you see 0x, and like when you're dealing with Cisco, you'll see 0x, and then when you're dealing with other places, you'll probably see the little h right beside that. So that all signifies hex. There are also lots of charts like this, like how to go to howtoanswer.com, and they show you, hey, whatever hex number you're looking for. Like if I was looking for C, C equals 1100 in binary. Just don't rely too heavily on this. You can use stuff like this to check your work, but you should be able to figure this out on paper, because eventually you're going to have to. You know, either for tests or for interview questions somewhere in your life, you're going to need to know this if you get into networking. So make sure that you understand it and you can do it. So again, to test yourself, you know, find your MAC address and convert it to all binary and then convert it to decimal. So remember, your MAC address is 12 digits, but it'll convert into 6 binary bytes, and then convert those 6 bytes into decimal, and then you're all set. And then you can check your work with a chart like this. All right, don't forget, it may seem like, oh, how many times do I have to convert a MAC address, things like that. That hexadecimal is not very important, but remember, the world is moving to IP6. By the time you graduate and you get a job and you work your way through the entry stuff and you get into the network admin position, the mid-level, IP6 is going to be a lot more mainstream than it is now. And IP6 is all based on hex. So if you don't know hex, you're not going to know IP6 and you're going to be lost. So focus, make sure you're good with this. And again, I always take very detailed notes, because the problem is, as you're doing IP math or subnetting, you only do it, you know, when you focus on this section, and then you move on to other subjects, and then you graduate and you're like, crap, well, how do I do that? I remember I did that in college. If you make your notes so that you can hand them to your mom and your mom can do IP math, then you know you're set. Then you can always go back to your notes, refer, and know exactly, you know, what you were doing. All right, next video is going to be on how to look at your IP4 address and find the network portion versus the host portion. So we're going to talk about how to use the subnet mask and how the subnet mask breaks up that host and network portion. So until next time, have a good one.